And we're live. Okay.
Mhm.
So, yesterday we spent like an hour running through a presentation on Autosar, which is used in the automobile industry a lot. And, Jagan had presented that. And today he is here with us. We wanted to have like casual chat with him to understand more of his background, what motivated him, things like that. So, as a starting question, Jagan, could you go back to your, let's say, engineering days and then walk us through what all happened and how did you become who you are today? How did that happen?
Fine. Fine. So I'm just recollecting. I did my engineering on electronics and communication, and a long back, way back in 2005 to 2009. So that's the
Okay.
time when I complete my engineering. So it's I would say after completing engineering, I want to try something on the core. So because I got uh, some fair understanding about I wouldn't say fair understanding. Uh, I got exposed to that's the right word. I got exposed to FPGAs microcontrollers towards um, 2009 or end of 2009 when I complete my engineering. And I learned bit of M scripting, MATLAB at that time, and those were the days where it's very difficult to buy something online, and there is no Arduino kind of a platform that was existing. So it was interesting. If I think it today, we have to go procure AVR chip, AVR
Hmm. Hmm.
pick
Big
16 F
chip.
or
Yeah.
pick
Yeah.
18 F kind of a board. I don't know. In Chennai, there is a place called Rich Street where you go buy this kind of. I think in Bangalore also there is one equivalent place.
SP Road.
Yeah,
That's period.
similar to that. SP Road is much better, I guess, but Rich Street, very, very popular area where if you want to go buy, build your own stuff. So I managed to found a shop. It's existing. It's called as Ajanta Electronics, and
Ajanta Electronics.
they're the one
Nice.
who are selling these chips,
Hmm.
the microcontroller board altogether. But
Fair.
it's not coming from a proper vendor or it's not a proper board.
Hmm. It's locally made.
It's a
Hmm.
locally PCB soldered board.
Hmm. Hmm.
But they said, see, this is the board that we have. We are selling everything separately. So you have
Hmm.
to buy flasher,
Hmm.
and they don't have proper debugger or something at that time. I'm so curious to buy that and explore because I'm building something. That's it.
Right.
I want to build a small prototype.
Hmm.
I literally have no idea. And the book that really helped was way back in time. It was a book written by Yashwant Kanitkar, Letters Embedded, I guess. Similar to Letters
Let us embed. Okay.
Similar to Let Us See, the book name is Go Embedded.
Go embedded.
Go
Okay.
Embedded, it is based on AVR platform.
Okay.
And they were the ones who were selling an AVR board also. You have to order
Hmm.
an AVR board,
Hmm.
and that they'll be shipping that from Nagpur. So
Okay.
it was really difficult to learn embedded system at that time. I still
This is 2009.
Yeah, 2009,
Wow.
and one very good way for learning embedded system. Embedded system is a eighth semester paper. I exactly recall. It's an elective paper, and we have officially studied microcontroller 8051, 8086, 8085. So
Hmm.
all those were lab kits. So
Hmm.
when
Hmm. Hmm.
I was looking for a prototyping board, Electronic Value magazine and Go Embedded was a solution. And the other option that I could find is a Richestate. Richestate didn't help me because I failed to design a proper power circuit or a power supply for that board.
Sorry, which board was this? I missed it.
Which one? It's again
Jo-
the one that I bought from Richest Status
Aj- I
Pick
see.
18F. Achanta Electronics is Pick 18F.
I see.
But luckily, this Go Embedded, they made a educational board which is based on AVR, which again I ordered through this,
Hmm.
I think,
Hmm.
Yashwant Kanitkar. They
Hmm.
had, that
Mm.
time they had this solution.
I'm just, Jacob, I'm interested in the price point, if you recall. Like,
Yeah. Even
there is
at
a
that
very,
time, yeah, around the 3,000 rupees.
Oh
3,000 at
wow,
that time.
wow.
Around,
This
yeah,
is
that board. I think
2009.
still we can Google it, and that board
Mm,
it's a Atmel 328P platform,
mm,
Atmega 328P.
mm,
It's a 8-bit controller, and the whole Go embedded book itself is a book that is explaining about the bare metal programming.
mm,
Mm.
Oh
So,
wow.
yeah, I was experimenting all this, and I didn't actually land in a proper job. It was this a kind of a market risk. So I have to took a job in a small what do you say, so-called project center. So I started my career.
mm. And we also have to recall that it was 2008 time where economy was like
Uh,
Crashing, yeah.
yeah,
completely in the
yeah,
dust, right?
yeah.
So,
I have an offer, but I was
mhm,
waiting to join. I was not
right.
called by the company.
Mhm,
All these things are happening. So there is two opportunity. I have to either go continue that job, or I have some liberty to pursue my masters. So
Mm-hmm.
right.
it was the 2008 and 2009 thing
Mm,
that made me to do my masters.
mm,
While doing masters, okay, all these embedded related things was interesting for me, and there is no chance for us to buy a FPGA board. We can't even
Hmm.
think of buying or affording a
mm,
FPGA board. And I was learning HDL, VSDL very long at that time.
Hmm. 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 Hmm.
These things were interesting for me.
Hmm.
And the only place for us to learn is NPTEL. It's not YouTube or it's not
mm,
others. So NPTEL is a very formal place, and I remember there was one professor who officially put a ARM course in NPTEL, and you can't able to stream. Uh, and you can't able to watch the video. You literally have to download the video. And I remember
Yeah.
NPTEL used to sell their content in DVD.
Yes. Yes.
So it was that time. So I used to procure the DVDs, and I was working in this project center, and I got some decent exposure again on embedded system. So what we do is typically a project center job is like you build things without any idea. Like you keep everything ready. You should have
Hmm.
a code for all the interfaces and different platforms. If
Hmm.
somebody comes, you have to mix and match. You have to create a project and you have to give. So
Right.
that's how
Right.
and it's a seasonal business. Usually it
Right.
happens December to May, and I was working there between June to September.
Hmm.
mm.
And the project, this place would cater to whose project? The student projects or the industrial
Student.
student? Okay,
It's
nice.
again it's another place like the what do you say? Chennai's Moore Market.
I
That's
see.
student by their project, but
Hmm.
hardly I worked there for 2 months.
Hmm.
Mm,
Then I got a so I was hunting for writing GATE exam or giving some
Hmm.
mm,
exam and joining some sort of masters in embedded related course. So I picked up few options in India or in Tamil Nadu. Okay, so overall decent embedded course offering universities at that time. So
mm,
so FPGA was our VLSI was more better option when it comes to ME. I don't know. People were
Hmm.
offering
Hmm.
more of VLSI kind of a course, very less direct embedded system course at that time.
mm,
So what happened? Then I add some other options also, like going for automotive embedded system or going
Hmm.
for medical electronics. You
Hmm.
either pick automotive electronics or you either pick medical electronics. These options were also there,
Hmm.
and these are very niche. And it is
Hmm.
okay. Directly, we know it is directly. We are going to study embedded system. Although we say
Hmm.
medical electronics,
Yeah,
these
right.
are
Right. It is.
basically embedded system. So
Right.
some title that was very interesting for me that time. So there was an university in Tamil Nadu who offered. I don't still it was not there now. Who offered a course named as Pervasive Computing.
Privacy
so
computing.
Pervasive. It's
Pervasive.
pervasive.
Okay.
always.
Yes, pervasive computing. What we
Interesting.
call it as IoT today, that was pervasive computing.
Pervasive computing.
Yeah,
I
so
see.
the word IoT was not so popular at that time.
Back then, huh?
Then the university where I studied, a PhD college,
Hmm.
it's a popular place in Coimbatore. So, but they are starting automotive, and they are opening up that for electrical electronics students in
Hmm.
2008.
Mm,
And nobody picked, and I got an opportunity. I didn't get a what do you say a very aligned embedded course. So
Hmm.
I picked automotive. I'm not a car enthusiast or a bike
Right,
enthusiast.
right, right.
Nothing like that. Because of embedded, I went there.
Mm.
So
Ah, see, that's how.
that's how I landed embedded and the good reputed college. Because of that, I picked automotive. So
Right,
there I
right,
got a
right.
chance to learn automotive.
Right, right.
And
And then, good, good.
yes,
Complete your
yeah.
statements.
And the interesting part is when I joined there, I got some very good faculty who maintained NXP sponsored lab, Infineon sponsored lab.
Hmm, hmm, hmm,
It was
hmm.
not NXP at that time. It was I exactly remember it was in 2009. The lab was called as Freescale lab. It
Ah,
was
okay. And right, right. Later, NXP.
Freescale. Okay, next check. Freescale was the daughter company of Moto. So Moto chips were branded under Freescale. So
Free
it was
scale.
Freescale S12 series of microcontroller, and I Freescale was conducting a Freescale autonomous racing event.
Events. Yes, yes, yes. I
Uh,
recall hearing about it. Yes,
it was very
2016-ish. Yeah, it was popular. I heard about it in 2015, I think.
in
14, 15.
2015 and 2016 it was taken over by NXP.
Mm,
So I was telling the time of 2010, 2010,
2010.
2011, yeah, 2010. So I had an opportunity to properly learn embedded system, where like theory, practice, and there was a problem, there was an event. So it
Hmm.
was a very good experience for me.
Right. And
And
how?
yeah,
Mhm.
yeah.
Go ahead, go ahead, go ahead. No, go ahead, go ahead.
So since I'm a person who is doing the master degree there, so the faculties are very, very friendly. So they used to give the lab keys to me. I will have access to all the hardware, whatnot.
Right, right. I can very much relate to the lab keys part and trust part because I think until you are in bachelor's, everyone assumes you are a junior, naive, you have no idea what the world is, this, that. And when you come in for masters, people trust you a lot
Yeah,
more. And
yeah.
I think master students are more, in general, more serious because, well, one chance for campus placement is gone, or something bad happened because of oops,
Yeah,
wrong place.
exactly.
Yeah, so people are more serious. Yes. What I wanted to ask you was, could you maybe go back and recall what kind of subjects did you have, and what kind of, let's say, workflow did you have? Did you work more in labs? How did the subjects relate to each other?
Yeah,
What was
yeah,
that?
yeah. So the course actually was coming under the Department of School of Mechanical Engineering,
I see.
and it was led by the automotive department,
I
and
see.
there was a course on automotive uh, systems. That's a
Mm.
very course where they talk about all the automotive system, like different domain, powertrain, infotainment, telematics, all this. And there was one subject on automotive instrumentation where they talk about
Mm.
different types of sensors, actuators that is used in the vehicle. There was one course on automotive control system. So
Hmm.
that talks about modern control theory in application with automotive. And there was one course on vehicle dynamics. So
Vehicle
you
dynamics. Okay.
so, for me, it's dynamics and control specific to vehicle. It's a very I would see that is a very interesting part that I
Hmm.
learned because at bachelor's level for me control system I can't able to appreciate to that extent.
Yeah.
Whereas
Yeah.
at the
Yeah.
master's level, I understood the bit of dynamics and I understood that control, modern control theory concept. And
Hmm. Hmm. Hmm.
so I got some decent exposure. These are the subjects that I studied. Then
Right.
the second semester and the third and fourth semester is entirely devoted to two projects, two bigger capstone
Nice.
projects. And
Nice.
since it's a floating classroom most of the time, there are many courses that you can voluntarily audit if you are
Hmm.
interested, and there are many courses that you can skip. You have
Hmm.
that freedom. But these are the
Flexibility.
major subjects that I studied.
Nice.
And
Very
there is one
interesting.
course on electric hybrid vehicle, one course on power electronics.
Hmm. Hmm. Hmm.
Things
So
around.
looking back, do you, well, because you mentioned all the subjects, I'm wanting to take a guess, and then you can confirm, deny. I think the most important ones would be, which are still relevant today, would be power electronics, control theory, and wait, one more.
Yeah.
Control
Dynamics,
systems.
vehicle dynamics, I
So,
would say.
sorry, which one?
Vehicle
Dynamics.
dynamics.
Yes, yes,
Yeah, vehicle
yes, yes.
dynamics. Obviously, automotive embedded system. As part of
Yeah,
automotive embedded
fine.
system, yeah, we studied the S12 microcontroller and
Hmm.
all in-vehicle communication. I still feel which is really relevant is the in-vehicle communication part.
So, could you speak to that a little bit? So,
Yeah.
in vehicle communication, meaning the
So
protocols, or
yeah, exactly. Protocols. For example, like we have SPI, I2C, UART. When we
hmm.
talk typical embedded system, uh, we want to either interface to a sensor or we want some simple protocol using which I will send some data to other microcontroller. But in
No.
automotive, see, there would be hundreds of ECU, and these ECUs needs to be always communicating. So we need some sophisticated protocols. So
Hmm.
there comes your FluxRay, CAN, Ethernet, LIN. So there should be trade-offs also. We want to accommodate a low-cost protocol, low bandwidth, low data rate. That's absolutely fine. But I want that. So you have LIN. I want a good, decent enough error tracking protocol, the industrial standard. You have CAN, and I want super sophisticated, high costly, high bandwidth, more reliability. You have FluxRay, and there are provision where I don't need real time, but I want lossy data, but high bandwidth. You have Ethernet.
Mm, mm. But then,
So
if there are hundreds of ECUs that are wanting to talk, they are talking to whom? Like, is there a central entity that they are talking to?
there will be that depends on the vehicle architecture. So there are
Yes.
different kinds of architecture. Again, you have if it's a distributed system, there will be multiple gateways. So
Hmm.
if that gateways would be converting one form of data to other form of data,
Other
and
form.
one
Okay.
protocol to other protocol, or even it's a pure architecture architect's decision. So you either connect the camera to adaptive cruise control ECU, or you connect what do you say the MEMS unit
Hmm.
or
Hmm.
ICU unit to electronic stability program or ABS, and you
Hmm.
calculate and you send the calculated value in the network.
I see. I see.
So that's how it's a separate topic altogether in automotive, which is heavily relevant. It's called as E&E architecture.
Sorry, E and
E and E, you would have seen this E/E architecture.
E slash E. Okay, E and E. Fine.
E&E architecture, electrical and electronic architecture for
Hmm.
automotive. So
Nice.
that's actual very big job that job market it has. You will see that in automotive. You can
Hmm.
look for electrical and electronic specialist E&E architectures. At architect level, you will find many E&E architects.
I see.
At
Okay.
vehicle level, at vehicle level.
Wow. Well, this is new information to me. I mean, I think, I'm personally lost in the PC, phone, that kind of embedded space, but this is very interesting. I'll ask you one other question which relates to automotive, which, well, it scares me actually. Maybe you can, help me get over it. So I've always thought as to, in case, I'm assuming electric cars also use the same protocols, because
Yes,
why
yes,
not, right?
yes.
So let's say if any of the cars were to get into an accident situation where some of the wires are disconnected and all of that, what happens? I mean, then the communication is lost, and then the
Yes.
things cannot communicate
So,
with each other.
see, it's not the problem with electric vehicle. It's a problem with conventional powertrain. Even normal CASA engines also have the big wiring harness, and they come with a very rigid connector. And even the electronic control units were packed with a very strong case,
Protective layer. Acha,
protective case,
case.
and the I would say the mechanical part is very robust.
Robust.
So that is one way, but if it's a severe accident, yes, all the things,
Then it's all bets are off. Yeah, yeah, yeah.
yeah, all the things will go off. But the good part is any issue that they design, there will be a mode called limp home mode. Limp home, LIMPHOM. Limp home mode is, let's say, for example, if the critical sensor, let's take um, the sensor that is responsible for calculating the amount of fuel that needs to be injected into the engine.
Fair.
Okay, so
Very
if
critical.
very critical. If that is not there, if that sensor is not there, obviously that calculation is going to give a
Go
wrong
wrong.
result. So that is managed by an exhaust oxygen sensor, and that is managed by how much amount of throttle that I am pressing. These two sensors, throttle position, exhaust oxygen. Now these two sensors are getting failed. Okay, then, then will you think the vehicle will stop running? It should not,
I
right?
mean,
It has to run. Still,
it
it
should
has to
it
run. Still, it has to run.
yeah, it
Still, it
should.
has
I
to
mean,
run.
it should gracefully fail. Like it should slow down or
No,
something like that.
but okay, let's all of us driving a petrol vehicle or a diesel vehicle. Do you think it will run? It will still run, and it will not give the efficiency as it is designed to be.
Ah, I
Okay,
see. I
so
see.
which means that is what I mean by limbo mode. Even everything, all your sensors are failing, all the electronics are failing. Still, the mechanical system will work, and it will
Wow.
bring the actual and the engine remains to be run. But as a user, I will be indicated with some sort of malfunction indicator. Apart, there would
Ha.
be a OTD message or diagnostic message. So
Hmm.
that's how all these systems are designed. So it's not like every sensor is critical. We know even if
True.
the airbag sensor fails, we know the airbag is not going to get deployed. But vehicle has to. It's not like okay, I am unable to calculate this parameter. I am not going to inject fuel now. It should not take that risk.
The
But
true, true, true.
mm, but
It does.
some sensors are very critical, right? For example, the power steering ones. What if that fails? Then
Yeah, the
would
power.
they switch
No,
to?
the power steering once if it fails, okay, it operates as a manual steering.
Okay, I didn't know that there is a provision in the
It
design
has
for that.
it has to be. It has to be. It's whatever we call it as power steering is a power assisted steering.
Mm-hmm.
Hmm.
Manual steering, which is assisted, you don't want
Correct,
to
correct.
apply that
Right.
amount of torque because there is a column assisted motor or a row
Mm-hmm.
assisted motor. So that's the setup. So every system, see, if your electronic stability program is not working, okay, or your ABS is not working,
APS.
that system is not working, but it doesn't mean mechanically your vehicle is good.
Mm-hmm.
If we are so reliable on only the sensors, let's say they at a quality standard they call it as parts per million. So
Mm-hmm.
if these many parts per million vehicle is, let's say, a crash sensor, its failure rate is around 5 ppm. So which
Hmm.
means
Parts in million.
millions a sensor is getting produced, 5 can go wrong. What if that fifth sensor is installed in my vehicle?
Hmm.
Mm-hmm.
So finally, as a mechanical system, it will work. It has to be robust.
But then this is the case of the conventional IC or diesel car, right? What about the electric vehicles? I mean, they
If
are
it
all
is a
powered.
no, no, if it is an electric vehicle, yes. Again, the battery stack itself is under our chassis. The entire
Hmm.
battery stack is under our chassis, and there would be many redundant components. For
I
example,
see.
it's the entire battery will not fail together. It's arrangement of group of cells. There could be a
Hmm.
row of battery cells
Hmm.
going wrong. There would be a battery management system for isolating it.
Hmm.
Always the challenge with automotive is how do you come up with these kind of backup plans? So much of
Hmm.
backup plans, so much of standards, and so much of what do you say? Um,
Redundancy and failure
Redundant, yes.
proofness. Yeah.
Yeah, so much of things to be monitored. Let's take this X by wire system. X by wire is you can drive the vehicle by wire. Like steering can be by wire, which means there is no mechanical connection between steering and the end
Hmm.
wheel. So the data is transmitted via a wire, and there is a end actuator, kind of a motor, which is aligning, adjusting your wheel. And this information is very critical. Imagine
Yes.
you are holding a joystick and
Yes.
you are turning left and right, and the wheel is not turning, and you don't get the feel also.
Yes.
Even for that, there is some haptic feedback is there, but
Hmm.
still, steer by wire is a popular feature in the racing cars.
Racing cars. Yeah.
Racing cars. So there they use flex ray. So and there will be two channels of flex ray running, redundant.
Mm.
So
And if
even
one.
though data is redundant, the ECU would be physically there would be two ECUs for having this fault tolerance.
Wow.
Again, it's I'm going to build only one race car, right?
Wow.
That's how it is. So
That is,
automotive even to certify the vehicle is functionally safe is not an easy job. That you need a functional safety auditor, and the auditing process is big long. So much of functional safety architects are working at various stages,
wow.
at various stages
Wow.
of development. Because
Right.
if I release a the product to market, and the recall is going to
Hmm.
damage my name, my reputation, as well as huge loss.
Mm.
Okay.
Rather, I will spend one more year and bring the vehicle to the market.
Hmm. 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 Hmm.
That's how many standard OEMs who are into this business for decades, they will not show any urgency in bringing up the product to the
Mm.
market. That's
Hmm.
but
Understandable.
I think if you mess up this part, no, the result would be
Deadly.
disastrous.
Really
Yeah.
bad. Yeah. Yeah. Catastrophic. Yeah.
Mm.
Wow. It,
I suppose
it
it's
is.
hardware release is like but on steroids. You want
Yeah.
to
Yeah.
have
Yeah.
as much.
Yeah. But then this is still like, what do you say, automotive, right? What about like
Mm.
medical
The
and aerospace?
aerospace, yeah.
That's
Aerospace
more
E-
is like,
even
oh,
that's more
ECU not
critical.
working.
That's more critical. And kind of standards what they are adapting in
Mm.
automotive are from Arrow only.
Right,
Hmm.
right,
Now,
right.
but now automotive has become so complex because people are talking about autonomous.
Hmm.
Mm-hmm.
If you
Hmm.
consider L4, level 5 autonomous,
Mm.
that system is way more complex than a
Traditional one.
airplane.
Yeah.
Fair,
Yeah. Yeah.
fair.
Airplane. That's how it is.
Wow.
And Jegan, I have heard this, and this is like a very naive info which I have is in aerospace, the machinery, especially the electronic circuits, are designed to be interlocked, and there is a voting mechanism and all of that. So a piece of code runs like thrice, and then vote is collected based on the result, and whichever wins is.
In automotive, I at least
You have come
uh,
across that?
I have not come across
You have.
some sort of voting, or in automotive the
Mm-hmm.
standard practice is having E2E error correction modules, end-to-end
Mm-hmm.
correction, usage of watchdog is very heavily.
Mm-hmm.
Whenever things are not there, automatically it restarts.
Right, right. So
I
I
we
see, there is a clear demarcation. In normal phones and laptops, computers, you don't have such robust and
Hmm.
reliable
yes,
protocols.
yes, yes,
Then
that's
there was a need to make one, so automotive and Autosar and all of those specifications came in. And then you have like the last layer where you cannot have anything going haywire. So
yes,
there you would
yes.
have like redundancy in terms of even electronic components.
Exactly, exactly.
Interesting.
Exactly. And there are
Hmm.
people heavily use again soft sensing techniques. Let's say, for example, I might be needing a parameter which I cannot able to measure directly,
Hmm.
like sleep. How do you measure sleep? But sleep is a
Hmm.
very
Kind.
important
Hmm.
quantity.
Right. Right.
Sleep is a very important quantity needed for electronic stability program, needed for ABS.
Hmm.
So we don't have sensors to measure sleep. So we
Hmm.
fuse different data, estimate
Right.
sleep.
Right, right.
So
Derive.
it's
Mm,
purely a control system,
mm,
an estimator.
mm,
People really rely on this kind of estimator. Sometimes even your GPS signal fails. You use your IMU and other values act like
mm.
a local coordinator, local GPS coordinator.
Hmm.
So,
Wow.
in automotive, most of the time, a same parameter is estimated, measured in multiple places. They do
Mm,
that, but I've not seen this kind of voting mechanism.
Hmm.
mm. Fair.
Calm. Lot of Kalman filtering, I
Yes,
suppose.
yes,
Yeah.
yes, yes. A lot of Kalman filtering, EKFs, a lot of
Hmm.
sensor fusion, one
Hmm. Hmm.
other
Hmm.
form of sensor fusion, many table-based logics, many
Hmm.
interpolations, all these things they do.
Wow. Wow.
Yeah,
And
making
then
development very complex.
yeah, I mean, this is, it's kind of mind bending right now. But then I'm imagining that it makes sense that something like Autosar be made,
Hmm.
right? A common entity on which all the rival companies also come and contribute, because it somehow seems like this is a pain for everyone.
Mm,
Correct. Correct. See, how do I see is, let's say, for example, I'm a mechanical guy.
Hmm.
For me, I have to, if I may need to make 1,000 rupee, I have to sell 1,000 different product.
Hmm.
You are embedded a software guy. You are coming and you are selling something.
Hmm.
Okay, and
Mm.
you are making 1,000 rupees by selling one product.
One.
One product. And okay, still I'm buying. And
Hmm.
tomorrow I'm giving the same product and I'm saying make some modification. And you are telling no, no.
No.
For
Hmm.
me, this is a new product. I will build again from the scratch. Then obviously I have no other option to leave you, and the trust is also breaking. What I'm thinking, okay, you are making more money than me
Yeah, 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 yeah.
Mm.
to business, but you anyway you are going to build that one product, you are going to sell that to other guy. So,
Hmm.
Mm.
I'm still in that mechanical mindset. For me, everything is kind of a factory. I want that kind of
Mm.
execution, even the software also. So
Hmm.
you build a software that I can customize, I can reuse. That's where
Hmm.
this idea of Autosar started coming in.
Mm.
And based on the session we had yesterday, so what I understood was that Autosar is essentially like a designed recommendation, and layers are implemented based on recommendation, like
Yes,
already. And then if you are an application developer, an application in this context would mean, let's say, a braking system. So the
correct,
actual logic of the braking
correct,
system is the
correct,
application,
correct.
right? Hmm. Very, very interesting.
So even Autosar, what they have done is, let's say for example, I have been doing as a OEM, I have been developing software for last 35 years, 40 years, or 50 years,
Fair.
and I cannot go and change everything on one night, and from tomorrow I've decided to
Mm.
Hmm.
come to Autosar. It's not like that. So Autosar has given provision for us to evolve slowly. So they call that as implementation conformance class.
Okay.
ICC. So you can stick with ICC 1, ICC 2, ICC 3. You can slowly move ahead. Your first,
Mm.
let's say for example, you are a beginner. You for implementing AutoSAR, directly don't jump into building everything. Rather, you segregate your application separately and core embedded software separately,
Hmm.
and make your application with a wrapper and try to make it portable. Only
Hmm.
that part
Hmm.
is, and the remaining thing can be what do you say, a black box or a proprietary software.
Hmm.
That's
Hmm.
also an AutoSAR. That's also a recommended conformance class in AutoSAR.
Hmm. And when you were referring to, you can stick by ICC 1, ICC 2, the you refer to the developer or the company? Like,
Uh, for not for the developer, for
I
that
see.
system, for that
I
ECU,
see. I
for
see. I
that
see.
for that ECU.
That means OEM, right? The
Yeah,
OEM
yeah,
can
for
stick to
OEM,
the.
yeah,
Okay.
OEM. So let's say, for example, I am implementing a body control module. So
Hmm.
body control
Mm.
from all the body control functionality would be managed by one electronic control unit.
Mm.
And
Hmm.
I want to try out AutoSAR and I want to see what is the benefit of AutoSAR. So I'm as a OEM, I'm starting that from my body control module.
Mm.
Because that's
Hmm.
a simple thing. So
Hmm.
let's try there. So even there, they are telling don't directly roll out everything. So first go a step by
Mm.
step. You try ICC one,
Right.
Hmm.
so that you will you will understand what is AutoSAR. Because so for a OEM to work on AutoSAR, they again have to set up a team. They have
Mm.
to stick with a tool vendor because many of the decisions that they have to take on the first day. On top of that decision, they
Mm.
have to make.
Right. Right.
So they
Right. Right.
want expertise. They want
Mm.
that what do you say? That embedded group as part
No
of the
house.
team.
Yeah.
And most of the time they will have application experts. They might not have embedded experts.
Mm.
I see. I
And
see.
and, and that's not their business also, right?
Hmm. True.
Why do you think OEM wants to build an operating system? That's not
Mm.
there. But
Hmm.
now
Correct.
there are multiple OEMs who are building their own operating
Mm.
system
Hmm.
because they want to like lead the SDV
Hmm. Hmm.
wave.
Hmm.
They want to lead this SD
Right.
software defined vehicle wave. So
Right. Yeah.
I don't want to name any OEM, but there were
Mm.
many OEMs. There were one particular OEM who set up a or who kind of a spin-off company building OS, and there is one company who is building the OS on name of their popular
Mm.
product. So everybody is building OEM. Sorry,
Yeah.
building
Wow.
operating systems
I
for
And
suppose. Go ahead.
this.
yeah, I was going to ask if this race to create their own
Mm,
OS for SDV is a result of AI, and the second one is the increased compute. So is this what you were
Yes,
referring to,
yes,
adaptive Autosar?
yes. Because of the increased compute, because of the complex problem that they are trying to solve,
mm,
they want, and they are also exploring other revenue streams from this
mm,
Gen Z. So one is like going for yeah, going forward. No one knows like we will have that kind of auto enthusiast buying the vehicle.
mm,
People are so fancy, right? They
Hmm.
want autonomous vehicle. They want some sort of
Gear, hand,
entertainment
yeah,
there. Yeah, vehicle to be
stick
a
shift.
kind of
mm,
part. So even OEMs are thinking the next gen vehicle should have capability to have autonomous, electric, and all the software, application, firmware, driver, everything should be updatable, and certain services can be unlocked, can be disabled.
mm.
It should be subscription
Subscription
based.
based. Yeah.
Even autonomous, even
Then
autonomous
No.
can be subscription
they
based.
will they are planning to show ads during signal, when you're waiting for the signal.
Yes,
Yeah,
but from a old generation or a
mm,
conventional vehicle user,
right,
for me it's very scary.
right.
So I'm buying
True.
everything. I'm buying everything, and they are telling subscribe for autonomous, subscribe
Right.
Mm,
to make your vehicle autonomous.
Man, I'm not going for,
mm,
yeah, software defined vehicles. I
So
like my.
we will see. We are talking in 2025. We will see that in
mm,
2045. Nobody knows now.
I see.
mm,
Okay, yeah, that's far out. So,
Yeah, it's too far,
gee,
but it's like someone has uh, why Google is with Android, or why they are having Wear OS, right? The
yeah,
same
yeah,
same reason, the same
mm.
reason why people were trying to build OS.
yeah.
That's all. That's all.
Very
And
interesting.
and Jagan, do you happen to know if they like there is a compliance certification which happens? So if an OEM says, let's say I'm Autosar compliant, does that consortium also grant the certification to the OEM?
No,
There
no,
is
no, no.
no such.
It is, let's say, for example, if I'm a OEM, I have to give a compliance certificate saying my vehicle is functionally safe.
I see. Hmm.
It's functional safety. So every ISI standard will have, ISO standard
Hmm.
will have, right? So this ISO standard is called ISO 26262.
Okay. Oh.
That
Hmm.
that is for any electrical electronic system that gets into the vehicle, especially electronic
Hmm.
hardware and software embedded system that gets into the vehicle. Who has to certify? If I'm an OEM, if I'm selling a vehicle in the market, I have to certify that I'm functionally safe.
I see.
And
Hmm.
that embedded system, I'm using a AutoSAR stack.
Hmm.
I procured from a vendor,
I
and
see.
that software is certified that I had ensured that this software that I'm selling is
Hmm.
functionally safe. Let's say, for example, if I'm buying a software Autosar stack from my ex vendor, and he is
Hmm.
giving me an evaluation version, and
Hmm.
that evaluation version will say, "Don't flash this software in your vehicle ECU.
Hmm.
It's not a production grade. It's
Hmm.
for evaluation. It's purchased." If it's a production grade, you need to buy a certified, as they call it as ASIL level, ASIL.
Hmm.
So it is ASIL D certified, ASIL B certified. ASIL D ASIL stands for Automotive Safety Integrity Level.
Hmm.
So these they have classified multiple embedded system into this multiple levels.
I see.
Hmm.
Hmm.
So if it's an airbag, it has to be following ASIL D standards. If it's
Hmm.
a rear lamp or a brake light, it has
Hmm.
to follow ASIL B standard. Or
Based on the severity of the.
severity, based on the severity.
Safety is.
Hmm.
Exactly based on the severity, failure,
Hmm.
and the impact that is going to create.
Hmm.
So
Okay.
based on that, they have classified, and depending on that, the kind of software that I put in, that usually as of now, the adaptive AutoSAR has come up to the level of ASIL B. If you are
Hmm.
Yes.
using adaptive AutoSAR, if you are using a processor-based system, it needs to be ASIL B. But
Hmm.
our people are trying that to bring that to ASIL D level. and
Hmm.
there were software vendors who are capable and who are selling that their software stack is
Mm,
actually decompliant.
mm,
Wow.
So
Wow.
that's how it is evolving.
mm.
So we also then discuss around adapt, adaptive and
Adaptive.
Yeah.
adaptive autosar.
Adaptive. Yeah.
So we also talked that C++ seems like the primary language.
Correct.
So maybe could you speak to the like why C++, and then also in passing maybe make a comment on like where does Rust stand given that it is memory safe and touted to be
Mm.
safe and secure than
Mm,
C.
So the initial Autosar standard when classic Autosar that they laid right, the one very big thing that missed out is they have made that very clear. Nothing should happen. It's a conscious decision. It's not actually miss. It's a conscious decision when they are building the standard. They want none of the things should be happening in a dynamic way, which means you are not allowed to do any dynamic operation during that time.
Free malloc, all of
Yeah,
those.
yeah,
Yeah,
nothing,
mm,
nothing, nothing.
everything deterministic.
Yeah,
Perfect.
so
mm,
they want that whole stack to be used for deterministic purpose, and it is
mm,
very clear. But going forward, when you want to make anything, there should be some sort of plan time.
Hmm.
Even there is no scope for that also in classic AutoSAR.
Hmm.
And they build this implementation is done also with C only, C language in classic AutoSAR.
I see.
Then,
mm,
then what happened? Now we are laying down a architecture which is
Hmm.
going to be really futuristic. So where my assumption is the underlying hardware is not only processor, it can be processor, it can be a virtual machine, it can be on top of
mm,
an hypervisor. So they assumed all those possibilities. So now, okay, let's build the standards for containerized embedded system, and let's have C++ as our implementation language. Now, since C++ started coming, and even in this they have included accommodated features like OTA,
Hmm.
upgrading the application, pushing the application from cloud. For all
Hmm.
this, they want to have a module and they want to accommodate these features also as part of the standard. So
I see.
they with that assumption they started putting the adapter processor and they made the implementation language by default as C++ 14.
I
mm.
see. And when
So
did this start? When
in
did the notion?
2017.
Seven. Oh yes, you mentioned that.
Yeah,
Correct.
in 2017 only the consortium is thinking about releasing the first cut, the first version
Uh,
of adaptive AutoSAR. When I say version, their objective is to release only the standards, right? Only the
hmm.
specification. Somebody has
Right.
to take specification, have to build a product out of it.
Mm,
So we don't have a very mature product.
I see
Uh,
ecosystem.
yeah, so in 2017, 19, I remember in 2018, 19, many companies were building small modules in adaptive stack. Now we have some product, at least a complete full-fledged product.
Hmm. Wow, interesting.
And because C++ also as a language has seen a big evolution,
Lot.
right?
That is
Between
true.
11, 14, 17. So
Hmm.
this was also happening on 2017. I think that could because now I am learning adaptive AutoSAR or I am supposed to deliver adaptive AutoSAR training. I'm not an adaptive AutoSAR guy. So now
Hmm. Hmm.
mm,
Hmm.
because of this requirement I am learning and I see
mm,
Hmm.
lot of by default use of proxy skeleton design pattern. I saw
Uh,
by default usage of promise and futures. The
oh
value
wow.
mm.
the asynchronous programming, the exchange of data between
Wow.
different
Man, we
threads.
have gone from no dynamic allocation to promise
A
key.
sync and
Yeah,
IO.
Wow.
yeah. So future promise everywhere. The default data exchange
Mm,
mechanism is future promise,
mm.
and
Interesting.
the basic assumption is they built all this on top of assuming the vehicle has full fledged Ethernet in the running
Mm,
between the vehicles. That's the first assumption.
wow. Mm,
Wow.
So, so still you can
Wow.
ask me. Still we can think not all the vehicles are having Ethernet running, but
right.
the
Fair.
communication is happening,
Mm,
assuming that there is Ethernet and the protocol, the
mm,
middleware layer is based on some IP. They are calling it
mm,
as SOME IP.
Mm.
Very
Uh,
interesting.
But I think this is an interesting segue to, coming back to the classical Autosar, and you are famous for that. What are the topics, because a lot of our audience we anticipate would be, recent college grad, and they would want to align themselves towards the field of automotive. So what all, topics would you say in embedded are relevant, or, they should know if they want to lay their hands on the automotive side?
what I will do, I will break down all possible job roles that you will have in
Right.
AutoSAR
Awesome.
market. Yeah. So one is a AutoSAR verification validation engineer. You can be a verification validation engineer for base software or for the
Application.
application software.
Mm.
In both the cases, your role is to know where the data is passed and what are the layers that it is crossing and how at each layer it is getting transformed,
Mm.
and finally what's the end thing. So what is
Mm.
the expected result, whether I'm getting the expected result. So you should have some basic understanding about everything, even to work in verification and validation. So
Mm.
verification most of the time done by the developer itself, uh, at a unit testing level, and static analysis, all those things are verification part. At a validation level, sometimes they do a lot of stub coding. Only one module would be ready, remaining part will
Mm.
be, and we will do integration testing. So these kind of work uh, is what I see most of the freshers deployed. If it is
Mm.
in the application space, most of the time the application is built with a tool like MATLAB, Simulink,
I
Stateflow,
see. I
Mm.
see.
and they because sometimes if you are an application developer, you end up working with OEMs very closely.
Mm.
And you don't want to be a C programmer actually, but you will be a um, control system guy,
Hmm.
or you will be a image processing guy, or you will be a core automotive engineer also.
Hmm.
You know what exactly you are building, and that has to be tested. For that, there is a standard workflow. You take the model, you do model in loop, you do software in loop, you do
Hmm.
hardware in loop. These kind of testings. So these, so either if you want a verification validation engineer at application level, learn mill, kill, sill, understand engineering basics, and
Hmm.
understand automotive basics. Learn MATLAB Simulink,
Mm.
learn model-based design. This is purely from a engineering perspective. Then
Hmm.
on purely from an embedded perspective, learn basic Autosar. Again, understand the standard verification validation principles. Understand the overall. They used to follow a V standard, V kind of a process, not like a
Mhm.
regular water flow model. It's a V kind of a model.
Okay.
So in V flow model, or it's called as V development cycle. In V development cycle, at various stages, what kind of validation that you do.
Mm.
Hmm.
And it's a standard, and you need to know in which which ESPICE, or sorry, which what do you say, stage of V development cycle that you are working. Whether you are
Mhm.
working on integration testing or you are working on unit testing, so that you know what you are doing. Most of the time, what I see, freshers doesn't know why I'm doing it, what I'm doing.
Right.
Mhm.
It's a useless job. So they get bored with embedded, and they get bored with automotive itself.
Right.
Mm.
And,
Understandable.
and they started doing MBA or something, and they do different things. We have
And
seen,
they usually come back to the same question.
correct,
Mm.
why I did engineering, all those things. So we have seen a lot.
Well, I was hinting at why I did MBA. Yeah, I
So
think very
that's
cool.
that's one big pillar of job market, verification validation. Second one
Mm.
is your Autosar integrator. So Autosar
Mm.
integrator is like, let's assume you are working for one OEM in a tier one company, and you are responsible for building the software in that one single EC.
Mm.
So the OEM has bought the stack, Autosar
Mhm.
stack, and they have given to you, and they have given the requirement also. Say this is going to have 4 CAN channels, and this is going to have oh, these are the messages going to come, which needs to be stored in NVM. So they give all the
Mm.
requirements. Now you need to understand the tool, you need to understand the stack, you need to configure all these things. Then you need to generate the integrated code. You need to
Hmm.
generate
Hmm.
code. You need to integrate all the source code together. Then you need to compile it. This is the
Mm.
most complex job, because there is OS.
Hmm. Hmm.
And all these things are written by somebody else. and it is
Mm-hmm.
tool generator. And finally, after doing all this, the application also need to be integrated.
Right.
So this guy have no clue about what is happening at the application level. But
Mm-hmm.
he knows, okay, this message is coming, and this message has to go via CAN channel. This message is
Mm-hmm.
coming. It has to be returned to NVM. This variable is coming. I have
Right.
to pass this variable to other application. So he will have that entire blueprint, and their team would be integrating. So this guy
Mm-hmm.
should be a top-notch C programmer. It's a classic Autosar. You should be a very good C programmer, and you should be open for debugging.
Mm-hmm.
Hmm.
When we stitch all this together, we don't know which one will go wrong.
Mm-hmm.
Hmm.
And we should be
Right.
very open-minded, like put his hand directly and debug any code, whether the code written by me, whether the code
Somebody
written
else.
by
Yeah.
some tool, whether the code is coming from the stack. You should patiently
Mm-hmm.
put his effort in debugging. So this is AutoSAR integrator.
And what are the options when it comes to debugging? Like, is there like a hardware debugger?
Yeah. You have hardware debugger. It's finally it is going to be the microcontroller.
I
In
see. Okay.
AutoSAR. So the typical debugger, but only thing is the microcontroller that they use is the automotive grade microcontroller.
I mean, that's at the hardware level, right?
That's at the hardware level, but debugging level you don't see any major
Understandable, right?
Right.
change.
So we talked
And
about two parallels.
Two
Just
parallels. Yeah.
refresh
The
it.
third
One
one,
was the
yeah,
application
sorry, one was
developer.
application
Then this
developer,
was the integrator, the Autosar
integrator.
integrator.
Hmm. Second is Autosar integrator. Third is
Hmm.
okay. So I one is verification and validation. Second
Hmm.
is
hmm.
the Autosar integrator. Third one I would say application developer. He's not a
Okay.
Hmm.
validation engineer. He's a developer.
Hmm.
So
Hmm.
what he will do, he will get the requirement, he will get the engineering requirement, or he will get the business logic requirement, and
Hmm.
he will translate that requirement into a model,
Hmm.
and then he
In
will
things like MATLAB?
MATLAB simulate. Yeah,
Hmm.
I see.
it can be a C program also. He can directly
Depending
Hmm.
on complexity
depending
and
on
all of that.
complexity. Depending on
Okay.
complexity, let's say if it's a powertrain issue where I cannot do a hand coding, then I will go with MATLAB simulate. If it's a
Hmm.
simple system, it's a gateway issue. It's not going to
Hmm.
do big application. Everything is handled by the base software, depending on
Wow.
that issue. So the
Hmm.
application engineer. So mostly this guy also would be a application engineer, control systems, machine learning, image processing kind of a guy.
Hmm.
The fourth one is it's not a kind of a fresher role, architect role. So who is giving all requirements for everything?
Right.
The guy who defines the architecture for their entire vehicle are is part of that entire vehicle architecture team, and he is defining requirement for one ECU.
Hmm.
So
Hmm.
this guys would be typically the functional safety expert, E&D architect, or he would be typically a network architect. So they are making all the
Right.
decisions. So
And for someone to go, let's say, from application developer all the way to an architect,
uh,
what's like the usual path?
so it's like you can, so let's say for example it has happened for me also. I in the initial stage I worked at hardware in loop simulation hill.
Hmm.
Then slowly I understood about MPD. So
Hmm.
I worked on building a steering logic. I worked building on some powertrain ECUs logic. Then uh, building some library for application. Then slowly I understood the Autosar stack, DSW modules. So I understood the work of integrator. Then slowly I understand a tool like Prevision. So over the time, over the period, obviously you will be pushed in this direction only.
Nice.
Hmm.
That's how
Hmm.
everybody working. And sometimes there are people who grow in that direction itself. It's not like if I
Hmm.
started my career as verification validation engineer, I can grow. I can master that and I can grow there itself. I know everything in
Hmm.
the,
Hmm. Hmm.
and somebody will be
Makes.
directly starting their career in base software developer, DSW
Hmm.
developer. Yeah. So now, if you ask me which company to look for different roles, it's not all same company, right?
Hmm.
Right.
Usually OEMs will look for MDD guys. OEM, when I say OEM, car makers. If you
Hmm.
are seeing a job opening from R&D these days. it would be on IMDb kind of workflow. Or if you are seeing a job opening from MBRD, it's a typical thing, but everybody is doing all these jobs, all the works. And again, if it's a tool development or stack development, company like Electrobit, company like KPIT, so whomsoever is developing their own stack, they do that.
Could you expand the short forms that you use, MBID or MBIR? You were
MBRDA. MBRDA is
yeah.
Mercedes Research Center India. MBRDA. Okay. Research
Exactly.
and Development India.
Okay.
So
Wow.
basically, it's Mercedes Benz.
I see.
Yeah.
And then what I was going to ask is, and in all of this now, just now, heading towards, I see that we have like about 5 minutes to at least, conclude today's conversation, and we can have a follow up wherein we. Okay, so for follow up, I have an idea. I want to propose that. How about we take the open source documentation of the Tesla Roadster
Hmm.
one and sit with that, and then go through. Okay, this is this, this
Mm.
is this, this is this. Just
We'll try.
exploratory. I
We'll
mean,
Mm.
try it up. We'll try it up. I have
yeah.
not done that myself, but we'll do that
It
as
Yeah,
doesn't matter. We'll
on
just
the
yeah.
fly.
explore. Yeah,
We'll
and
do that
we'll
as an exercise. Yeah.
yeah.
That will be I think interesting.
Yes.
Yeah.
So we'll
We'll
keep
Mhm.
that as the
see what are
second
things.
follow.
Yeah.
Fair.
We'll
That
see
we'll keep that
what are
as a
things that they
follow.
opened. Yeah.
Yes.
Yeah.
And well, so for today's session, towards the conclusion, maybe can you speak to the role of Rust and
Uh,
mandatorily the where do
Yeah.
you see the AI thinking going?
Hmm. In adaptive Autosar, I see they given some documentation related to Rust.
I
So,
see.
which means you can implement a model, or you can implement something with Rust. Maybe I also have to revisit that. But
Fair.
other than that, I didn't see any much direct. Like in Linux kernel, they have provision to incorporate Rust, right?
Rust. Yes.
The
Modules.
same
Yeah.
way, the same way the in adaptive autosar stack, the basic assumption, the OS is any POSIX operating system. If you are using
Okay. Then that can be in Rust and things
Rust,
like that.
yeah,
Yeah. Fair.
other than that, the big usage of Rust in automotive is not that
Hmm.
uh, big or
Mm.
so serious, but I think it will come.
Fair.
It will
Okay.
come.
Okay.
Because
And
again of the memory,
memory leaks
Mm.
and
memory.
safety. I think
Yes.
that's well. I would say Rust instead of this is my opinion.
Hmm.
Rust instead of being a language feels more like compiler work. Like a very cleverly designed compiler, and then because at compile time it tries to check every
See,
allocation or manipulation of data. So that is something very good. Okay, then maybe to final question, and that is AI and where is all of that going?
so AI, yeah, everybody is testing. So because a lot of work got eased with AI now. So
I see.
when it say like if I'm a verification validation engineer, AI can do a lot of my work. I can speed up many of the activity with AI, and if I'm a developer, that can. But what I feel, and again, in all this activity, we are trying to ensure that the product, the finished product is functionally safe.
Okay.
To speed up this, you use AI. It's not like
Mm.
I build everything with AI and
Mm.
that itself is going to do the task.
That's not happening.
That's not the case. And again, so then somebody is going to tomorrow ask whether the AI that you have used in this is functionally safe.
Okay, makes sense, and that's
So
well,
nobody can able to certify that.
Tricky
yeah,
Okay.
one
yeah,
too. Yeah.
Yeah,
yeah.
yeah. So
Only
it,
one AI can certify another AI in that case.
so we have to wait and see. That's my
Interesting.
answer. That's my answer.
Fair.
Uh,
Interesting.
we will see what AI has got. We don't know at the moment.
True. True. True.
Mm.
But as of
Wow.
now, I'm seeing it as a tool to speed up or improve the productivity.
Productivity. Yeah.
Mm.
Yeah. Definitely. Wow. Perfect. Cool. So I think at least for today's session, I do not have any follow up. Well, actually, I do have follow-ups. I don't want to take it up in today's session.
Fair.
Okay.
So yeah.
That is
So
that I will take it out separately.
yes, we'll
Mhm.
we'll have a follow-up, and let's discuss there. So one of the things that I want to say before we conclude the session for today is, and this is for our viewers, which is we have been working with Jegan on the topics of Autosar, and one of the interesting collaborations we are going to do is Jegan is going to work on a course for Autosar and bring his expertise to the table, and that we should soon see. Again, soon is tricky because we would want to let Jagan have the liberty to develop the content as he sees fit. But it's just that it'll come to the platform. Yeah, I think with that, Jagan, thank you for sparing your Sunday afternoon for us, and it
Definitely.
was a pleasure to have you. Yeah.
Thanks
Yes.
for your time, and it's a nice conversation.
Yes, it's
Mhm.
it's a fun one. Yeah.
Yeah, thank you.
And I'm going to go ahead and then end the recording.